Okay, let's continue our review for the Unit 3 lecture exam in geology. And we need to know, where do you find earthquakes? Most of the time, earthquakes are going to be generated at plate boundaries. So the first one is going to be a plate boundary where they're being pulled apart. So that's going to be a divergent plate boundary. And then we found that the ocean could be pulled apart, so that's where new ocean floor forms. And then we also said you could have a divergent plate boundary underneath a continent, and then that would cause the continent to break apart. So you tend to have earthquakes wherever these plates are being pulled apart. They're not going to be major earthquakes, but you are going to have earthquakes when this happens. Okay, then you got the transformed plate boundaries. So now you're going to have more severe earthquakes where plates are sliding past each other. So an example, this is going to be the San Andreas Fault. Then you have convergent plate boundaries, and so the most violent earthquakes are going to be associated with subduction zones, where you've got one plate that's going underneath another plate, and then it gets stuck, and then pressure builds up on it until it finally slips, and then when it does, that generates the earthquake. So at subduction zones, so this could be where a ocean plate is going underneath a ocean plate. It could be where an ocean plate is going underneath a continental plate. So both of those are examples of subduction zones. Okay, then you could also have whenever a plate hits a plate, and then that forms mountain systems. So you can also have very severe earthquakes as a result of that. You can also have intra-plate earthquakes. And so this is going to be caused as the magma is coming up to the surface, it gets into the rocks, and it breaks the rocks apart. That generates an earthquake. But most of the time, earthquakes associated with interplate activity is not as severe as the subduction zones and the transformed plate boundaries. So how do we measure earthquakes? So the first one is going to be based only on the amount of damage that it produces. And what does the earthquake feel like? So it's not a very precise way of measuring an earthquake, but you should know this Mercalli scale for the exam, and the bigger the number, the more damaging the earthquake is. Now the Richter scale, on the other hand, is a more mathematical, it's a more quantitative assessment of the damage produced by the earthquake, because it gives you an idea of the amount of energy produced by the earthquake. And so in order to use this, you need to know the amplitude of the earthquake, and so you get that from your seismometer. So the needle that is jiggling up and down during the earthquake, you're going to measure the maximum amplitude, and then you find that on one side of that graph. Then on the other side of the graph, you need to know how far away the earthquake was. So once you got those two pieces of information, you connect the two with a straight line, and then where it goes across that center one, that's going to tell you the strength of that particular earthquake. So you should be able to do that on the exam. And now this picture just shows you the amount of energy produced depending on the strength of the earthquake. So you should be able to, if you are given that picture on the exam, you should be able to read the picture and then tell me how many earthquakes of that magnitude occur per year, and then the amount of energy released by it. Okay, then you have the moment magnitude scale. So you should know this one, and it's a magnitude scale at the epicenter based on how much energy it takes to slide one patch of rock against another one. And the scale is going to be similar to the Richter scale. So what determines how strong an earthquake is going to be when it finally arrives at your location? So it depends on how big was the initial earthquake to begin with. So the larger the initial earthquake is, then the stronger the earthquake's going to be by the time it makes it to your location. Okay, it also depends on distance. And so don't worry about that formula, but it's a 1 over r squared, which means that if it travels 1 unit of distance, then it's going to have a certain magnitude, a certain intensity. But if it travels twice the distance, then 1 divided by 2 squared is 1/4. So then that means you're only going to feel 1/4 of the amount of energy released by that earthquake. If you're 3 times the distance, you're only going to feel 1/9 the amount of energy. So the further you are from an earthquake, the better. It also depends on the material that the waves travel through. So some materials transmit earthquakes better than others. And it depends on the frequency of the waves. The higher the frequency, the more energy the wave is going to have when it reaches you. So how do earthquakes cause damage? Okay, they make the ground shake back and forth, or it makes the ground shake like this, or it could cause it to go like this. So all of those different kinds of ground shaking can damage telephone poles and buildings. It could trigger landslides. If there is water in the ground, then that vibration will cause liquefaction. And so that makes it easy for buildings to sink into the ground if that ground has a high water content in it. Also, the ground can rupture, so it can break roads and bridges. Okay, you should know what a tsunami is, and you should know how tsunamis form. You should also know that earthquakes can rupture pipes, and so they can cause fires. So, now that we know how much damage an earthquake can do, then can earthquakes be predicted? So first thing is to identify places where there have been earthquakes. So if there are a place where you have a plate that's going underneath the plate, so that would be a seismic zone. If you have a place where plates are being pushed together, that could be a seismic zone. Past history of the zone. So there could be places where the plates are diving underneath the plate, but there hasn't been an earthquake in 1,000 years, so chances are there's not going to be another earthquake in another 1,000 years. But if you see evidence that an earthquake has occurred 100 years ago, and then an earthquake occurred 200 years ago, and then an earthquake occurred 300 years ago, well, then you can predict that every 100 years there's going to be an earthquake. Okay, if you notice that stress is building up along an earthquake zone, then there's likely, given enough time, it's going to rupture. If you notice that there is movement across the zone, so if you notice that a fence is bowing or a fence is moving on one side compared to the other, then that means that an earthquake could happen. If there is a series of small earthquakes, those could be foreshocks that are going to tell you that a big earthquake is going to occur. And then you've got these unsubstantiated signs. So these are signs that have been used in the past to indicate that an earthquake is going to occur, but there's no scientific evidence as such that an earthquake is going to occur if water levels in wells change or if gas begins to come out of the ground, for example. So how can you reduce the damage caused by earthquakes? So the first is to have an early warning system. Second is to be prepared for an earthquake. So that would mean to take all of your things like TV sets and water heaters and bolt them to the walls. To have a earthquake kit, so have food and blankets ready just in case an earthquake occurs. Uh, Earthquake zoning, so be careful about where you put your buildings. Okay, then if you do decide to build a building, then engineer that building so that it can withstand an earthquake. So the buildings can be flexible so that they can wobble but they don't fall down. They could be braced so that they would be stronger. They could have shock absorbers in the foundations that allow the base of the building to be able to move. And then the avoidance of using concrete blocks and unreinforced concrete and brick. So there's your review for this lesson. So now when I come back, we're going to start talking about geophysics.